So here is how you define an image mathematically. Okay.
Hmm.
So you use this Python imaging library. So you have an image. An image is nothing but a set of matrix of pixels.
Hmm.
You know matrix, right? What is the matrix?
Yeah.
So this set of pixels define so therefore that's why linear algebra is very important because an image is a matrix actually.
Hmm.
Okay, so if you want to rotate the image, you have to rotate the matrix. What does it mean on the rotation of the matrix, right? So
Hmm.
that's why complex numbers sometimes come in lot. So in Python, you have already did you work with NumPy as of now?
No, sir.
Okay, so I think that should be the goal this week. So the first week of Python was mostly about understanding the data manipulation. Okay, then the next
Hmm.
tip is how is data stored.
Hmm.
The data is stored using NumPy and pandas. So in a for pandas is for a data frame and NumPy is used for mathematical operations. Okay,
Okay.
it's a matrix. So now you must have heard about tensor. Did you hear about PyTorch, tensor, these things before?
No, no.
So let me write down these things in your. So let's go to session two. Session two is all about. So session was mostly about Python intro and
Hmm.
disease understanding, right? Now session two will be mostly about like the session like the second class will be mostly about um, data manipulation. Rather, I would say ML in Python, linear
Hmm.
algebra, image processing. Um, I would not go into. Let's just focus on image processing and this. Okay. So the whole idea here is let me share something. Just look into what I'm writing down. Okay. Can you share that screen of what I'm writing down once? Can you open the folder once?
This is which one?
No, no, no.
This or
Go to
this?
the folder, the drive folder of the session two.
Yeah.
Yeah, I think yeah. Go to the Dragonfly project. The
One second. So
fourth tab. The tab
which
beside the
tab?
left hand side
Ah.
of yours. No, 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 no. The tab.
Oh, this.
Yes.
Okay. Yeah.
Yeah. Go to session two. Yes. Refresh. Control R. Yes. Go to notes. Yeah, I'm writing here. Okay. So what you need to
Okay.
do is first of all, as of now, you understood. Uh, Session was mostly about understanding what is Python fundamentals, right? Now
Hmm.
the next ideas is how to manipulate. Now why I'm writing this down because you can use this keywords to search in GPT later on. Okay,
Hmm.
how to manipulate data, right? How does one store an image in Python? The answer is matrix, okay, or tensor. Now why tensor is coming, I will be coming up. So that's why you use NumPy. Ever now you see that which Python library is used for matrix manipulation for linear algebra, let's say NumPy. Okay. Now that's why this is the reason you need to learn linear algebra. Okay. Got it?
Yeah.
So I think session two's goal should be NumPy, linear algebra, image processing, in Python. Okay,
Hmm.
fully. Uh, uh, and for the image processing, you will be use cataract images. Okay, and we will also be talking about. Okay, so let's talk about the goals of the project now. Why we are doing this?
Hmm.
So you see, you have already done this. Now, can you go to the cataract page, the cataract document? It's open there.
Yeah.
Yes. Go down. Go down to the image where you are showing the difference between normal patients and normal
Okay,
patient
this
image.
one.
Yes, yes. That stay there. So you see that, you know, let's say you're a doctor. How will you look into this? Like, tell me the process. Let's say you have an image. Okay, you
Hmm.
have this normal patient image. Tell me a process you are actually doing inside your brain to see which is cataract or not. Tell me the simplest thing that is, like, whenever there's a big problem, try to find the simplest
Hmm.
problem, right? So tell me the
Yeah.
simplest thing you will do, you're doing with your eyes, understand your mind, to detect between cataract and normal eye using the image.
So first you look at the pupil, right? And then you'll see if there are cloudy patches present on the pupil, you will conclude that there's cataract. And if
Yes,
not, then it's normal.
and detect cloudy patches inside the pupil. Very good. So this is the whole idea. So now that's therefore the first step should be extracting the pupil from the image. That's
Hmm.
why image segmentation is needed. Okay.
Hmm.
So therefore step one is extracting the pupil from the images. That's not an easy problem. Okay.
Hmm.
So that's the whole idea. Um, so a pupil is of circular shape, right?
Yeah.
So the natural question is that how can you detect circles in an image, right? Even okay, this may be hard. What is a simpler problem? Can you ask? What is a simpler shape than a circle? Tell me.
Uh, like a line or something, a
Exactly.
point. I don't
So how can
know.
you detect a line in a image? Okay, and that's where image processing comes.
Hmm.
Okay, so your goal is next week is to understand linear algebra. Not much,
Hmm.
but that is needed for image processing. So you see
Hmm.
that your goal is NumPy linear algebra for image processing in Python. Cataract and other images. Great. So now how can you detect a circle line in an image? Okay.
Hmm.
So now let's go back to the PDF file that I have shared with you. Yeah, that understanding images. So go down. So that's why this is the first step on the right hand side. You can see how to do it. You can learn it from GPT. That's not a problem, right? But the goal
Hmm.
is there's an image. That image is, so now you see the image is saved in multiple ways, right? An image comes from outside actually. It's saved in JPG, PNG, all these forms. So each of the compression, those are compression algorithms, right? Like
Hmm.
how it's compressed. Those are saved inside this PIL. Like it's doing the uncompression and changing it to pixels. Okay.
Okay.
Now it's saved in a NumPy. You can see array, NumPy array, np.array. It's saved in a NumPy array.
Hmm.
So it's loading the image and it's saving in an array. This image underscore array is nothing but a matrix. Okay.
Okay.
So this is what you have the whole access to the mathematical access to the whole image. Okay. Now go
Hmm.
to the next one.
So, sir, in terms of an array, it's a 2D array or
It's a 2D array. So essentially, each point, each pixel is nothing but a number. Okay. A
hmm.
number. So you tell me from the observation that if a number is higher, it is more brighter or it's more darker. So tell me
It's
from the
brighter.
observations. If the number is higher, it's brighter, and if the number is lower, it's darker, right? So that's how it's
Yeah.
represented.
Okay.
Okay. So let's say you want to detect a white circle. So you will look for white regions, right?
Hmm. Yeah.
Now can you search brain tumor MRI just for a change of topic? Yeah, just search any one of them. Yeah, go to the third image, or maybe go to the um, first image. And you can see that brain tumors are generally brighter, right? In the second image, there are different types of MRI. So in the
Hmm.
second and the first, brain tumors are brighter. So you look
Okay. Yeah.
for a threshold after which, one simplest example to extract brain tumor is you look for a threshold after which it's all bright pixels, right? And that will give you an
Hmm.
kind of location of the brain tumor. Make sense? So
Yeah.
this is how it's used. Like first you express the image as matrix, and then you try to operate some, do some function on that, and then try to extract what you need. That's the whole idea. Okay.
Right.
Similarly, here we will also look for cataract. For example, if you can detect the pupil, you can now count that how many pixels have positive, like large intensity values. That means it has
Yeah.
cloudy, right? Because more
Right.
white, right? Makes sense,
Yes.
right? So that's how you use it. So one good problem for you is, this is a problem statement, I would say. You can try to solve is, take a cataract image. You can go to the class notes. Yes, very good. Change into grayscale. Okay. Once you change it into grayscale, you extract the pupil region. So now I will say that collect as 10 cataract images and 10 normal images, eye images. Okay.
Hmm.
Extract the pupil region, calculate the ratio of, or rather I would say, calculate the, okay, so calculate the histogram. You know histogram?
It's a plot, right? But I don't
Yeah.
know
Okay.
exactly.
Okay, I would say calculate the,
We can find the average brightness of cataract versus non-cataract.
yeah, mean of cataract versus non-cataract. Okay. And yeah, and normal. And from this, next day we will understand probability distributions from here. Okay.
Hmm.
Because a cataract is nothing but all the intensities. If you open it up, it's a kind of distribution, right? That's
Right.
where we will understand probability distributions from there. So next day you can do this till this part, and this is one problem statement. I think a good problem statement for you. Yes. So, and you see, so the thing is that how to extract the pupil region. Okay.
Hmm.
Uh, you can download them, you can crop them up. That's one choice. But yeah, and you see, and you
So,
will
sir,
see that.
do I have to crop it or do I have to write in the code to extract it?
So if you can do it, that's great. But how will you do it?
Hmm.
So that's the
Yeah.
whole idea, right?
Hmm.
So if you can try to find out a method, so we will try out different methods, like getting a
Okay.
circle detection. Okay. So this
Hmm.
is one problem you can try to solve. Problem one.
Okay.
Okay. Before that, this is problem. Okay. Uh, s- So this is this week. I would say, yeah. Okay. Um, this one is done. Okay. So now coming back to linear algebra. This is what I wanted to do. Okay. Before that, go to the PDF file. Great. So now go to the next page. Yes. So you can also print image array.shape. You can find this essentially. You can find out the image shape, right? Let's say you want to track those region. You want to specify which height and width of the region you need, right? The I comma j arrays. So I would say code it out, right? Code it out. Which, for example, one way to see is first plot the image array in this cataract case. Okay, first plot the image array and see which pixels are around, then code it to extract those rectangular shape. Okay, that box, and then apply. It's for the cataract image, I'm saying. Got it.
So sorry, can you repeat?
So let's say it's 389 comma 487. You get the cataract image like that. Okay, now you see that it's,
What is 389 487? The total width and length.
yeah, the height, the number of pixels and the number of pixels out.
Okay.
Okay, pixels is the
Okay.
smallest unit square.
Yeah. Fine.
Okay, that it captures. So the larger the pixel size is, the more blur it will be. Do you see the point?
Correct. Yeah.
Yeah. So now you see that you kind of, so now you can draw it on a graph, right? And you can draw it on a graph, and each pixel is nothing but some kind of coordinate system, right? So you can
Correct.
see that the cataract is around the coordinate system 120 to 150, and on the y-axis, and
Okay.
170 to 190 in the x-axis. So you
Okay.
extract this rectangle out there by coding. So you first
Got it.
look at that. So I will write down x of the pupil region by specifying the pixels. Okay, so you see, we are specifying the pixels. Our goal is to automate this process, right? By
Hmm.
AI. That can the
Yeah.
AI learn that which pixels are these from the images, right?
Hmm.
That's the whole idea. But we
Okay.
are automating this so that we are doing it by hand, because you need to know the data set, right? What it
Hmm.
is. Great. Um, okay. This is one problem. Okay, go to the next slide. Great. Now there is this colored thing, right? In this colored thing, this is very important for you to understand that when you see a color image, like let's say you take a snapshot of me or yours, it has three channels: red, green, red, green, and blue, RGB.
Hmm.
Now, why this? Because these are called primary colors.
Hmm.
Okay, you can make any color by a combination of these colors. That's why it's a
Yeah.
3D coordinate system. So any color. So now you can see this cube. So in that cube, you can take any, let's say 0.3, 0.2. So let me okay, can you search, okay, let me see, color RGB finder. Just give me a minute. Okay, so I am sharing one link with you.
Yeah.
Open it.
Let me share that. Yeah.
So you can play around with RGB values. You can see it.
Hmm.
Yeah. Play around. Yes. So you can see that you will get different colors.
Yeah.
Right. So now you can see that, for example, keep it here. Yeah. So you can see 12. So the maximum value of R is 255. So what you are now doing is 12 by 255. That amount of red you're taking. For green, you're
Hmm.
taking 194 by 2. So essentially, all the numbers are between 0 and 1. So essentially, it's a linear combination of, it's like alpha R of R plus alpha. So I will write it down. Alpha A. So R times red plus G times green plus B times blue is equal to a color where RGB between 0 and 1. Okay. So that's the whole idea. Okay. So, and A is for transparency. Okay. How much
Okay.
transparent opacity. Okay. But
Okay.
yeah, usually color is made up of these 4 dimensions. Now you see, now go back to the previous slide. The slide. You can close this.
Hmm. Yeah.
So now you see, um, if you look into it, so there is a red channel, there is a green channel, there is a blue channel. Each of them, so therefore an image is nothing but made up of these 3 matrices.
Yeah.
Okay. So an image is H comma W, right? So if it, so actually a grayscale image is nothing but an H comma W. Okay. But a colored image is nothing but 3 comma H comma W. Go to the next slide.
Uh,
Yeah, this is how you understand. So this denotes, go to the next slide again. Oh, go down, go down. Okay, I have not written it. Go above. So essentially a color image is nothing but 3 comma H comma W. Okay.
okay.
So the dimension. Okay. So the first the first one denotes, so this is the, I think the slides are over. So look at me. The
Hmm.
first, so it's 3 comma H comma W means what? There are 3 of H comma W, like 3 matrices, like this stack,
Okay. Okay.
right?
Okay. Got it. Got it. Got it. Yeah.
So the first one denotes the R matrix, the second one denotes the
Yeah.
H matrix, and the third one. Now this together, so every pixel is there for nothing but average of R plus G plus B. That's
Yeah.
how a new color comes up. Do you see the point? So it's
Yeah.
like nothing but together you are seeing all of them together. Okay.
Right. Stacking
So
them on top of it.
yes, so that's why that its dimension is 3 comma H comma W. Okay.
Hmm.
So this 3 is called number of channels. If it's there is an
Okay.
opacity thing, it's 4 comma H comma W. Okay.
Okay.
So I would ask you to explore, upload different images in grayscale and colors and explore the dimensions of different images. So the problem is, so this is a problem you should think about. Can you make, so a grayscale image is also an image, right?
Yeah.
So I would ask you to find out that the pixel of gray, the grayscale image, can it be
Hmm.
expressed as some RGB values? Okay. Can you go to the color picker once?
1 second. Sir.
Just go to another tab and
Hmm. I'm just paste there. Yeah.
now make all the RGB values equal. You can do it by, yeah, just make it, yes. You see the color, what's coming out?
Yeah. It's great.
Yeah, you decrease the amount or increase it. Let's say you make it 200, all of them. It's lighter gray, right? Because
Yeah.
why? Because the intensity increases, As the intensity increases, it becomes more bright, right? That's why it
Hmm.
becomes light, right? If you make all 255, 255, 255, it will become, guess what?
White.
Exactly. If you become all 000, it will become black.
Black.
What I want you to understand is the mathematical relationship between a grayscale image and a RGB image. Like, yeah, that's what I want to. So, what is the mathematical relationship?
So like how we can convert an RGB into a grayscale image.
No, it's like if you, it's like, so the idea is that every pixel is a combination of whatever the color is in the world. Every pixel is a combination of
Hmm.
an R, G, and B, right?
Yeah.
So I would like you to know that if you were to represent
Hmm.
a grayscale image as an RGB image, what it will be.
Right. Okay. Okay.
An RGB image is a gray. See, the whole idea is that why grayscale has only one dimension, RGB has three dimensions.
Hmm.
So the reason is, okay, so let me tell you the idea. You can explore it because otherwise you'll not understand. Or do you want to do it yourself, explore it yourself, and then come up with an answer?
No, so what I understand is you're asking me that if you give me a grayscale image, I can tell you what the value of RGB is. That's
Yes.
what you're asking. Okay.
Yeah. So the thing is that why grayscale image? So the question what I'm interested to
Hmm.
ask you is that why grayscale image is being expressed in one
Yeah,
channel.
because we only need one value, right? And we assign that value to all three RGB
Exactly.
because
Very
they
good.
all have
Good.
the same
This is
same
exactly
one.
the answer. We need only
Hmm.
one value for all the
Hmm.
RGB channels. If you
Yeah.
and that final value is nothing but the whole intensity. The 200
Yeah.
that you put, that is what. So essentially, a grayscale is nothing but all the points is x is equal to y is equal to z lines.
Yeah.
Do you see the point? If you go to
Yes.
that 3D image, it's nothing but
Yeah.
all the points on the x is equal to y is equal to z line. That is the diagonal of the cube.
Cube. Yeah.
So like from zero to that all the points on that are grayscale. And as you said, it's just need
Okay.
only one value, right? And that is the
Hmm.
intensity of the image. And if you can
Okay.
see, if you keep 100, can you go to the color picker? Keep all 100 except the R200. Okay, no, keep all of them 100 first.
Okay.
And now slowly increase the R. You see, it's becoming more redder. The redder component is increasing. Red
Yeah.
component is. Now you again go to 100 and increase the green. You will see the same thing, right?
Yeah.
So therefore, that's the whole idea. So that's it. Um, yeah. So therefore, our image is represented by this. This is what I wanted to understand. And so what I said that x is equal to y is equal to z, I expect you to do it yourself, but it's okay. You can explore it
Hmm.
yourself. Okay. So
Hmm.
now next, this is all about the images, right? You have understood the mathematics of image. Now go to the slides once. Yeah, go down. Go down. So now, so you use this image. Okay, image is stored in case of grayscale as 2D, but in case of color, it is stored as
Three.
three matrices, which is also named tensor. So it can be any c comma h comma w, right?
Hmm.
Can be c comma h comma w, right? So this together
Yeah.
is called a tensor. In
Okay.
imagine now, in you take a video now. Now you tell me like the dimension of the tensor is three dimension. Now you take a colored
Hmm.
video. What will be the
Hmm.
dimension of that video?
Four.
Dimension of the tensor of that video.
It will be four.
Yeah. Why?
So you'll have three dimensions for the color images and a fourth for time.
Exactly. So all the four dimensions, and that's what is a video.
Hmm.
Exactly. Now you can have videos from multiple cameras. Then it will be five dimensions, right?
Hmm.
How do you,
Hmm.
so essentially the whole idea is how do you store these values? Because once you understand how do you store these values, then you can implement mathematical operations on that. Okay,
Yeah.
very good. So next is this quick exercise that I want you to do. So I want you to study all these exercises because these are all important. Okay, so you
Okay.
understand what is a flipping an image. So it's a matrix.
Hmm.
So when you flip an image, so I would say this is a step I want you to do. Uh, Let me write it down. Apply all the transformations on any image you like.
Okay.
Okay. What are the transformations? Let me write it down. Flipping, zoom in. Yes. This is something you should do. How do you blur an image? But I will talk about blurring today. Can you do it from scratch using matrices only without any package?
Okay.
Okay. This is a hard problem. This will take you some time.
Okay.
Hard problem is you have to think about it a bit.
Hmm.
But this will give you a lot of insight about how images work. You will be fully confident that I can be sure. Okay,
Hmm.
got it. So also, I will be talking about this new thing called matrix operator. For example, let's try. Let's see an example. Let's say there is a matrix. Okay. Um, let's see. Okay. So flipping a matrix. I am using a PINB file in that meet. So let's say Just give me a minute. Okay.
Yeah.
Okay. So you go to the pynv file
It's in
in that session 2 folder.
okay. Yeah.
So I have imported. Um, can you refresh? Refresh again.
Mm. Yeah.
Yes. I imported a, so it's I am defining a matrix. Okay.
Okay.
So now what I will do is I want to flip the matrix. Okay. So an image is a matrix. I'm doing on a 3 cross 3. Okay. So that you understand. You can do it on an
Mm.
image. So if you flip it, can you refresh again?
Yeah.
So if you use this, so essentially this is the meaning of. So what does flipping mean? You can see it's flipping on horizontally. So
Mm.
understand what it means. It means that what remains constant, what doesn't remain constant. If it's flipped
Mm.
horizontally, what remain constant? So let's see, what does it mean? I think I should share my screen, okay? Because
Yeah.
it's too much of. So what does flipping mean? Flipping means that, let's see, I so essentially your goal is, here's an operation. Your goal is there is an ij and it's going to some I dash j dash, right? Every pixel is going to somewhere else, right? Every matrix aij is going to I dash j dash. How is
Mm.
it happening? What does flipping mean? Flipping means that at least I would say do it for 3 cross 3 for a 3 cross 3 matrix. Okay. So what does a flipping mean? A flipping means that I comma j, understand the mathematical very carefully, is going to tell me I comma j is going to
It's
flipping horizontal, let's say.
yeah. So it'll be minus I comma j.
Uh no, one is going to here, right?
Yeah,
So
like
what is
okay. So if
remaining
I
constant? Tell me
consider
what's invariant.
the
Tell me
two,
what's
five,
invariant.
and eight are 2, 5, 8, the middle
What, no, no.
column.
In I comma j, what is invariant? Which is not
Oh,
changing.
okay. J is not changed.
Very good. So it's changing the I dash. So therefore, I dash is equal to something and j dash is equal to j, right?
Yeah.
But what is I dash? I dash is nothing but 3 minus I,
Yeah.
right? Is it right?
Um. Yeah. It's no. It'll be uh two minus two minus I.
1 is going to 3.
Oh, okay. Yeah. If you
It's 4 minus I, right?
yeah, 4 minus I. Correct. Yeah.
Yes. So therefore, how can you represent this? If you observe very carefully, understand this very carefully. You want I to go to 4 minus I
Mm.
and j to go to j,
Yeah.
right? That means Just give me a minute.
Hmm.
Okay, that means if you observe that, you know matrix multiplication, right?
No, sir, I've not done matrices before.
Okay, so you should learn about matrices therefore. So
Okay.
okay, so if you go here, you will see that, let me see. Can you? So what I'm facing issue is in writing the. um okay, so here is a B C T, and here is the I comma j, and it's going to I dash, which is 4 minus I, and j. So how is matrix is multiplied? A matrix is multiplied like A times I plus B times j is 4 minus I,
Okay.
and C times I plus D times j is j. So you can easily
Okay.
understand it will be 0 here and it will be 1 here, right? What it will be? It will be minus 1, and there is no component of j, so it will be minus 4. But still, minus 1 times I plus 0 times j, but still its 4 is not there, right?
Hmm.
There should be
Hmm.
something added. So what should be added?
Hmm.
Sorry. This is the reason I don't know how to write here, but let's see if I can try. So it will be 4 added and here 0 is added. Now it makes sense.
Yeah.
4 plus, this is a matrix multiplication.
Hmm.
Okay, so let me express this. Much time it's taking. Yeah. So this is what I wanted to understand.
Hmm.
Anyways, I will upload this picture here. So you learn about matrix multiplication well, okay?
Okay.
And you understood about flipping.
Yeah.
Great. Very good. So you learn about matrix multiplication. So what I mean is that each one of them has a matrix multiplication behind it. Okay, and an
Mm,
addition, something like that, and a skill. So it's called linear affine transformation, where you're changing one matrix, you're multiplying. So I think before next week, I think you should be very careful with all these things. So essentially, you
mm,
understood linear algebra and NumPy, so you learn this for next week. Okay, and
mm.
session 3 will be guided towards convolution, edge detection. You will learn about circle detection. Um, I would say, and applications. Also, we will learn about histogram, all these things. Yeah.
So first I need to understand this linear algebra and I need to understand NumPy. Then I'll be able to work on the problems which you're
Yeah, but
giving.
I don't think it will take more than one day if you sit together.
Okay,
You
sir.
essentially have to learn about vectors and matrices.
Okay.
Uh, I will give you one video, okay?
Hmm.
Uh, I will give you right away one video. Okay, this video will be very insightful to you, and I'm sure you will love this. So, what? This is something I have taught
Hmm.
to start learning with, to learn the linear algebra. Understanding vectors, base vectors. What does vectors mean actually, and why is it
Okay.
helpful? Uh, okay, you can watch till the first 1 hour, and then you can let it go. Yeah. But the
Okay.
idea is that how in system of linear equations, okay. And next day we will learn about convolution. So why this is important? Because this is important for this uh, circle detection and stuff, okay, which we'll do later
Hmm.
next, and then talk about this. This is the basic idea. Um,
Okay.
uh, okay.
Okay, sir.
Yes. So next week we will do this, and let's see. And then on the week after, next week means after 2 weeks, and the week after
Hmm.
we will be doing more about. Okay, so I would suggest you this. Let me see. All these resources we will need for the next weeks. Some resources. So you can look into this image processing.
These are for image processing. Okay.
Yeah. So
NumPy
image,
and all.
you can say image processing is nothing but an image is a matrix, and image processing is nothing but applying mathematical functions on images to change it
Hmm.
into something. For example, let's say you have an image, and it often happens, right? And you must have seen. Do you use Google Photos?
Uh, yeah, I mean, I've used in the past. Yeah.
Anyways, so there are blurring image, and you can see
Hmm.
that people can remove the blur, right?
Yeah.
In Google Photos, there is a person behind, it's removing the person so that you are there.
Correct.
So what it's doing,
Hmm.
it's a matrix, and it's doing mathematical operations on the matrix. Okay,
Hmm.
that's the basic idea. The whole
Okay.
goal of AI is nothing but learning this mathematical operations. For example, we
Hmm.
are want to extract out the pupil. That's a mathematical operation, right?
Hmm.
So we want to
Yeah.
learn this mathematical operation. That's the whole idea, simplest. Now it
Okay.
starts with basic. As I say, whenever it's a difficult problem like removing a person from the background, right? The difficult function.
Hmm.
It's a very non-linear function. So therefore,
Hmm.
we will first start with linear functions, like
Hmm.
flipping. That's what we are doing,
Hmm.
and then we
Hmm.
will go, and then convolutional integration are a bit more linear, right?
Hmm.
And then after this, we will go into fundamentals of AI.
Okay.
Okay, and then we will go into computer vision with AI. Okay,
Okay.
and then so this is a basic idea. So the first 2 weeks we are trying to understand this.
Hmm.
Okay? And probably here we need some mathematics calculus classes too. This will take 2 classes.
Hmm.
But yeah, this is the basic idea. Okay,
Okay.
so yeah, all the best. I hope it was good. Any
Yeah,
questions?
sir. So just to recap what I need to do now. So what all had we said was
So you solve these 3 problems and read these images. Like
read those resources which you had shared.
yes, yeah, that will be great. And just
And
learn linear algebra. Okay,
okay.
okay. I will try to share a linear algebra resource with you. Bit. Yeah, this guy is really good. So if you go into the link
Okay.
I have shared right now, can you go there?
Yeah. Yeah. I share my screen, sir.
I cannot see your screen. Let me see.
1 second. Yeah.
Yeah, go down, go down.
Down. Okay.
I think you go to a different page.
So here is
Yeah,
this
yeah,
is
okay.
what
Go to the content section.
yeah. Yeah.
Yeah, go to the like vectors and go down, go down. Yeah, matrices. Yeah, you can read this matrices part. Go to the
Okay. Okay.
yeah, yeah. This will give you a good idea about linear algebra very well.
Okay. Okay. Sure. So linear algebra using that link, then I'll do NumPy using these links and
Now
I'll
those links
attempt
may
these
not
three.
contain NumPy. Um, I have to see. Those are you can read about NumPy. It's very easy. Okay. Uh,
Okay, fine.
I think it was in the video I have shared with you only.
This one.
Probably not. No, no. I remember the first video I've shared a big 5 hours video.
Oh, that no, sir. I went through that. NumPy is not there in that.
Okay, let me see.
And so otherwise, fine. I'll use like GPT also or something. We can see that. And then
No, no, wait, just give me a minute. You will get it. Yeah.
okay, okay,
It's a 1 hour video, so you will get it. Uh, yeah. You have to do NumPy, linear algebra, and image processing. Okay. Did you get it?
okay. Yeah.
Yeah. If you do this, it's good, and then solve these 3 problems.
All right. Okay, sir. So.
Yeah. Bye bye. All the best.
All right, sir. Thank you. Bye bye.